Shotade Olusegun. In today's particular live session, I'm going to actually, you know, I'm going to dissect what the physical reality of, measurement should be, what, the reality of the universe should be. Well, this particular live session is going to be quite insightful and informative because there are so many things that we're going to learn, and then we're going to, get the real reality of the universe based on novel research discovery, based on application of formula of everything. If you have been following me, you know that formula of everything is a novel derived formula, and that formula is used to unify quantum mechanics to classical mechanics. And then by unifying quantum mechanics to classical mechanics, I was able to get some facts about universe, and that is what I'm going to share with you here. Now, when you look at what I have on the screen, the title reads Quantum Mechanical Description of Physical Reality, Complete or Incomplete EPR Paradox. So EPR paradox, this is a paper which, was published by Einstein and some other two scientists like that. So now, there are some things I want to actually get from this paper so as to, drag my points home. So I'm going to be using formula of everything as it unifies quantum mechanics to classical mechanics to open our eyes to what the reality of the universe is, and then what the major thing about measurement problem is. You understand? Now there is this issue of having this superposition, or rather let me say we have this transition from quantum subatomic particle being in superposition to, a state of definite results. So basically, we're going to actually see what transpires, like what the, should I say, catalyst, something that actually calls for that transition for us to have the definite measurement in that regard. So now, when you look at what I have below the title, it says, in a complete theory, there is an element corresponding to each element of reality. Now, what this particular line is saying is synonymous to what Cantor did to actually give us what is known as countably infinite numerals, or should I say, okay, Cantor, he used set to pair, for instance, let's say natural numbers. So if out of the natural numbers we were able to get even numbers, even numbers, we have to be a proper subset of natural numbers. And by being a proper subset of natural numbers, then it is only ideal that even numbers should not be mutually exhausted when it is being paired with natural numbers. So if we could then pair the even numbers with natural numbers such that it becomes a O, impairing it with natural numbers, that it, you know, that it completes the whole series of natural number, then it means that what we have there is known as countably infinite situation. So this countably infinite discovery is highly essential because it is actually, pointing to completeness, which is what Einstein and other scientists were like trying to point out right here. And by having that, it means that there is this inherent nature of localization even in infinity. And as we progress, you will get to know why it is ideal for us to have instantiation of infinity as an entity, so as to be able to work with it, just as Cantor did. But then, in one of their facts here, they said we must have element of a theory, like having a peer-to-peer element combination, such that we have, every element of the theory to be paired with other element of what should be reality. So now, if we proceed, then we're going to say that sufficient condition, they now said sufficient condition for the reality of a physical quantity is the possibility of predicting with certainty without disturbing the system. Now, this might not, be the it might not be the sufficient condition, because we know reality is far more than what they are trying to, point out right here. But the fact still remains that if we can have a situation, we can have a point where there will be no disturbance, because when you measure, you interact with what you're trying to measure, especially when you're trying to make measurement at quantum level. Then you realize that you interact with what you are trying to measure, and by the virtue of that interaction, then there is going to be this issue of not being there will be this issue of not being able to genuinely measure what you need to measure. So I will actually use another diagram to, prove the kind of synonym, to prove the kind of situation, a kind of similitude, you understand, that can give us that kind of not being able to genuinely measure once we interact with what we're trying to measure. Okay, so now you can see the red part of the text where we have, however, the act of observing quantum system to measure its outcome disturbs the system. Therefore, quantum mechanics is incomplete. And that is the conclusion of the EPR paper of 1935. So the paper was published in 1935, and that was the conclusion. Now, this conclusion is highly essential because as we, progress further, we're going to get this fact that indeed quantum mechanics is incomplete. And so with that, we'll be able to get, what the picture of reality should be. Now, don't forget that I'm like trying to start from quantum mechanics and then build the system so that we can see how the reality, the picture of the reality can evolve. You understand? So now, let's now look at what we have below. The issue, the major problem that we have in quantum mechanics is for the fact that you cannot get to know a position and at the same time get to know momentum of a particular particle. And that is a big problem, because if you get to know the position of a particle and yet you are deluded of the momentum, then you can't get deterministic results. You can't predict, where the particle will be in the future. So you will not be able to get the mechanics of that particle's dynamic as to know where that particle will eventually land in the future. So now, for us to get the mechanics, just as we have, at classical level, like if I should hold a ball now, and if I want to throw that ball into a hook, by calculating where the hook is to where I am, and then by throwing the ball with that calculation in mind, then I can get to predict that yes, the ball will enter the hook or not. So by having the position of the ball at initial state, then by throwing the ball with the needed force, depending on your calculation, you can get to predict where the ball will actually land in the future. That is the kind of situation we have at classical level. So now, by having this situation, we know that if we can't get to know position and momentum at the same time, then it means that the position and momentum operators do not commute. And what that simply means is that when you have a flipped momentum in the universe, because please, I need you to pay attention to what I'm about to say now. Nothing can exist in the universe without being inversely related to another version, an inverse version of itself. You understand? So that is why we could have this two-way measurement of light. And that is why when you try to measure the relationship between distance and time, you know that time is the measure in time will be the speed of whatever object that you are trying to know how it can travel in space. The speed of that object will be squared, and that will be the measure of it in time reading. And by having that, it simply means that the speed of that object, the speed that that object will travel, will be that particular speed. That speed can only be measured in time when it is being flipped inversely to itself. So we're going to have multiple of that speed to have it in time. And by having that, we know that definitely we should have a kind of inversely related momentum for any object to be instantiated in the universe. And then you will get to see that in what I'm trying to explain right here. So now, By not being commute means that when you have C hat multiplied with P hat, and if that C hat multiplied with P hat is being flipped such that we have P hat multiplied with C hat, then the two are not equal. So it is more or less like having the singularity of the Big Bang, and then you now have the singularity of the black hole. Now, the convergence at the Big Bang singularity is different from the convergence at Big Bang at black hole singularity. So, the Big Bang singularity, we have energy density, and that is why we could have this inflationary suspension, or rather inflation right at the beginning. And so at the black hole singularity, we have this neutron star suspension right there. So by having the neutron star suspension, it simply means that there is this mass convergence that serves as resistance to that contracting phase of the black hole. So the mass worth that we have there is mass density. But then when you look at the Big Bang singularity, you know that the inflation that we have there is to, propel the expansion further. And so what we have there is energy density. So it's ideal for us. In fact, it is necessary to have this difference as we have it if we want to continually have momentum in the universe. So there is this inherent asymmetric nature in the symmetric nature of the universe's mechanics. So now let's look at what we have. If we are now to consider the commutator of X hat and P hat, then we're going to have the following. Now see that we have in square bracket, we have C hat, then we have P hat. And for us to get the difference between the two, we subtract the flipped version from the original version. So now you can see we have X hat multiplied with P hat minus P hat multiplied with X hat. So once we have it like this, we can just simply say that X hat is just simply X, because when you multiply that with psi function, you still have it to be X, and that stands for position. You can see what we have right at the top. Then we have P hat to be the momentum, and for us to have it to be a momentum, we're going to have it to be negative I H bar. So we're going to have I, that I stands for imaginary number. So we have that I, then we have H bar. Then we have partial derivation over partial derivation of X. So we have it to be d over the X, and that is the momentum. Now, why is it that the momentum has to be why is it that momentum must have this negative sign? It is ideal for momentum to have negative sign because when you look at it, the momentum of energy usually goes toward a low energy state. You understand? And the low energy state is the trajectory of negative sign. So now that we have that, that is our momentum. But then you can get to see that even this momentum is inversely related to position as we have it right here, because we're going to track the derivation of position to that momentum. And so if we have the momentum of position to be inversely related, with that actual momentum, then that is action, reaction, sign, action, reaction. So before we can have motion, we must have this action, which must as well have reaction in space. And so that is that. So I'm like trying to explain it in such a way that we'll be able to understand, and that is why I'm taking my time to explain every term of this commutator, or rather of this commutator. But then once we have this, what is the meaning of that? The meaning of that is that position will be inversely related to the momentum. So we have action, reaction kind of situation, and that will lead to relativity. Relativity, as we're going to have it, it's going to generate a central point between the interval of position to momentum. And so if position, and that will make position to travel inversely at the same speed with momentum, and that is the effect of relativity. So now, when you look at this IH bar that we have, you can see that I label it to be flipping operator. I label it to be flipping operator because when you look at it, this is more or less like the difference factor that would actually make momentum and position not to commute, the way I'm looking at it. Because this imaginary number multiplied with the h bar will have to be a real number, and so we can have a kind of complex system. So this is actually telling us that we have a trait of complex system in the momentum. I mean, as the momentum is inversely related to position, rather. Okay, so now let's go further. So now the next thing that we need to do is just to apply the commutator with psi and see how that will evolve in time. So now we have the x hat multiply with p hat and then multiply with psi. So by having this, then the value will now be negative IH bar, because that we are multiplying the psi with this value as we have it. So this initial value has to be different from the other value. So basically the multiplication will now be minus IHX. So I multiply with H bar, multiply with X, then we take derivation of the psi to in respect of derivation of X. So then we get to see how position evolve in time. That is what this derivation is all about. So now the inverse of this will now be negative I H bar. Now this one, we're going to actually apply product rule we're going to apply product rule of differential calculus to get the actual value for this inversely related commutator. And so we have it to be negative I h bar partial derivation to partial derivation of x. And so we then multiply the x value with the we multiply the x value with the psi. I didn't close the square bracket right there. I forgot to close the square bracket. So then by having that, then it means that we're going to take, derivation of x and then take derivation of psi. So we can do that separately by using the product rule derivation. And when we now take the derivation, then our answer is going to be I h bar, then square bracket x multiplied with partial derivation of psi over partial derivation of x, then plus psi. So now this value that we have here, we can quickly see that the answer that we have here is similar. I mean, we have common terms right there. So now when we move below, we can now say we can just take the two commutators together. We take the two commutators together by having square brackets x hat multiplied with p hat minus p hat multiplied with x hat. Then we attach psi to that, and our answer is going to be negative I h bar multiplied with x, then partial derivation of psi to partial derivation of x. Then the negative sign will be plus. So now we can see that the negative sign will then be plus because we have negative right here, we have negative right here. So it will be plus, and then it will be I h bar, then square bracket, we have the same term right there. So now when we cancel the like times, so one is negative, the other is positive, we can cancel the two. Then our answer is going to be I h bar psi. So now by the time we now take our x hat and p hat to get what the value we get, we realize that we have it to be I h bar, and that is not equal to 0. So now what I want you to understand is that by having this, it means that momentum and position do not commute. That is what it means. Okay, so now this is the phenomenon that we have in quantum mechanics. But then by having that, it means that there is this inherent asymmetric nature right inside the quantum mechanics. So now the difference factor as we have it is what I call the flipping operator. Like I said the other time, this I multiply with h bar, we move to the complex level, and so we're going to have complex system. And so we're going to have the toggling of imaginary number with a real number, because this h bar has to be real for us to have the complex system. So now the difference factor is the flipping operator at complex level. So now we need to take note of this. The h bar is too tiny to be significant at classical level, and that is the reason we could have deterministic result at classical level. So in that case, we can get to say that h bar is not at it is h bar is not at its real state because it is insignificant at classical level. So something is wrong. But then h bar is so huge to cause uncertainty principle at quantum level by the virtue of speed difference factor. So now at this level, h bar will be unstable, and so we can't get to know its real position. At classical level, it is so insignificant we can't get to, it is too tiny, so we can't get to measure to know its worth. So now at complex level, what do we have? H bar is real to toggle with its counterpart imaginary worth in order to flip momentum at the point of static and undulating transition, where localization and globalization can briefly be fused together as quantum entanglement. So now what I just read here is something that is so complex. You know, it is complex, just as the name implies. So basically, if we could not have the h bar, if we could not have the reality of h bar at classical level and then have its reality at quantum level, then it means that at complex level we should have its reality, because it will have to toggle with imaginary number, and because of that, then we can get to measure it. But that can only happen only when we have, when we have localization and globalization cohorting, you understand, to initiate or to instantiate that reality. So now it's a novel discovery based on what I've been trying to decipher, and then we get to see how this is so essential as we progress. So now it follows that experience, which is contact sensation, and observation, which is suspended sensation, must be fused together at complex level as emergent reality of objectivity that is void of disturbance ensured by superconductivity. So now conductivity is highly essential. Now quantum entanglement, if we have the entirety of quantum mechanics to be characterized with uncertainty, at what point can we have quantum entanglement? We know that by having quantum entanglement, we can get to have instantiation of what the real mass worth of particle is. But then we have globalization, but then the globalization is not without localization, because there must be this instant transmission of information from one particle to another. So we know in quantum entanglement we have, for instance, instantiation of electron to instantiation of its counterpart, which is positron. And so the transmission of information will have to be from one point to the other. So there is this localization at both ends, which the transmission of information must reach. You understand? So the transmission of information must actually move from one point to the other. So now that we have that, now let's see what solution of formula of everything is. This diagram as we have it is known as time energy wave model, and this is the diagram that I use to visually illustrate the solution of formula of everything. So now when you look at the right side where I have the T, the M equal to capital UM plus 4M, that is the formula of everything. This formula of everything is so powerful that it feeds back on itself. And what that means is that when you use an input, you can actually use your input by substituting the two M's in the formula with the value that you want to use. So when you use an input, it will generate an output. Then you can use the generated output as input to generate further output. So it feeds back on itself. Now, for instance, if we're to use, let's look at the bottom of this diagram where we have 9.109 times 10 raised to minus 31 kilogram. That is the mass worth of electron. So now if we substitute that in the formula of everything, that will give us the classical mass worth, which is 2,277,250,000 kilogram, which is this particular value. So now if we should put this value right inside the formula again to reconfirm the quantum mass worth, now you can see the way we are navigating. We're moving from quantum realm to classical realm. That is formula of everything for you. With formula of everything, we can actually track the decaying mechanism at quantum level to classical level. So we can track how decaying mechanism of quantum, or rather let me say how quantum decaying mechanism can actually affect the classical decaying mechanism. So we can get to see the amount by which the quantum particle is decayed to the amount by which the classical mass worth is decayed. So now, when we now put this classical mass worth, what we now get will now be this 5.7 times 10 raised to power 48. So the moment we'll expand that in standard form, we will get to see that we have a suspension, which is this big blue convergence at 32nd position. And so when we manually annihilate that, we're going to have this vertical trajectory. So we're going to have this vertical trajectory, which is also synonymous to, free fall, the classical free fall, which is the classical gravity. That is going to be spontaneous. So once you reach this topmost region where we have the big blue convergence, then the system will have acquired potential energy that will allow for that free fall to take place. But then don't forget that we only have the free fall right from the big blue convergence to this big red convergence. Now, right from the big red convergence, by the virtue of that free fall, which is the instant trajectory of time, we're going to have spontaneous symmetry breaking, and that will allow for mass accumulation, which I call arbitrary mass accumulation, because right inside the nucleus, I call this compacted equilateral triangle. At the edge, we have this compacted equilateral triangle. So that is the quantum nucleus. And by that virtue of compacted system, or by the virtue of that compactedness, or by the virtue of that, that compact of equilateral triangle, we're going to have constantly accelerated momentum. And by the virtue of that speed difference, that is why we're going to have, this uncertainty principle, as I said before. And so we can see that electron is not defined because of that huge temperature, pressure, and all that. Then we now see that there is this instant trajectory of time that progresses into the higher dimension. So that what we have there, we get connected to the electron of the higher dimension, which will be instantly converted to positron. And by having it to be positron, the electron of the substrate dimension, which is the, in its nucleus, will be instantiated, and what we have there is known as entanglement. So let me shift this. You can see quantum entanglement, and that quantum entanglement is a complex system. Why is it a complex system? Don't forget that it is only by having quantum entanglement that we can have that phenomenon of faster than the speed of light. And so it's a transiting point from the substrate dimension to higher dimension. And by the virtue of that relativity, or by the virtue of that entanglement, then we can have the instantiation of that substrate electron, the instantiation of the substrate electron. So that being said, it simply means that the higher dimension, which in this case is 3D, is being fused with the substrate dimension 2D. And what we have there is synonymous to having superconductivity. So the whole system is being cooled down to allow for that instantiation. And so the substrate electron will be fused with the positron of the higher dimension. So basically, for us to have that faster than the speed of light, we have to transit from the substrate dimension to higher dimension. So now, that being said, we now need to use the other diagram. We need to use the other diagram to paint what the reality of the universe would be. But then before I do that, we can get to see that by having entanglement, which serves as transiting point from substrate dimension to higher dimension, then it means that the wave collapse will actually be initiated by what we have up here, which is static and undulating field. So I call this vertical trajectory static and undulating field because it is instant by being vertical, but yet it has momentum by the virtue of its elongation. So now, definitely, reality that we need to portray, we have to allow for the reality that we need to portray, we have to allow for cohorting of observation and experience, or cohorting of globalization with localization. So now let's look at what we have here, proving the nature of reality with formula of everything. Now this is the formula of everything. Now the diagram is this tiny diagram as we have it right here. But then the entire time energy wave model is as a result of the application of this formula of everything. So now, for us to now dissect this formula of everything, we can get to see that the M is the energy's curve, while the T is the time's curve. The UM is strong conveying force, while the 4M is weak conveying force. Now, don't forget that I said that I H bar we have to serve as a flipping operator, because when you have multiple of momentum in the space which must be inversely related to each other, then there must be a point where we are going to have a flipping mechanism. So the best way you can actually visualize this is to think of two black holes. If you think of two galaxies approaching each other, so one is they are approaching each other. So if they collide, of course, there will be an instance where two of them will be detached, but the power of that and the power of the black holes at the center will make them to come back, and then they will then eventually merge. Now, what we have as reality is similar to this. There is a point where we should have static momentum, because the momentum, the inverse momentum of the two galaxies must be broken down, must be quenched at a point for us to have another, to have a reversed momentum. So basically, we can get to see that that detachment is not void of momentum. It is that tiny point, that tiny transiting point that we can have, position and momentum cohorting together to give us the reality of the universe. So now let's look at overview insight of reality. Overview insight of reality. So now I will have to read this. What will the overview insight of reality be? A man on earth, by being in contact with earth, which is synonymous to experience, will observe the earth to be flat. But by moving away from the earth to a certain distance, which is observation, he will then observe the earth to be spherical. So if he should go further into space such that earth becomes a tiny dot relative to its position in space, given that the earth moves away at equal speed to that of the man, only then is the tiny dot of earth is quantum relative to the position of that man as classical. So if we're to actually consider what could be quantum, what could be classical, we can get to see that it's a kind of situation where we have this, interval between objects. You understand? And then by the virtue of momentum, there will be length contraction. And so when it is being so contracted to the point where it is so tiny, we can actually liken that to quantum state relative to the classical state of the other object. So in space, we can only have classical state at one side, then have quantum state at the other side. So now let me now continue. However, if the man should travel further into space, but then before I continue, let me just say one thing. Now, you can get to now see that even by being at a certain interval to earth to get the real reality of the earth, the man will still be deluded of the reality of people on earth, because at that point, the man will not be able to have clear picture of people on earth, how they interact. So there is this trade-off in it. Now, however, if the man should travel further into space such that the tiny earth is out of his sight, given that the lost earth can be located by the man at the instant speed, only then is such transition from the known realm to the unknown realm is complex. So that we can now get to know what the complex system is, what classical system is, what quantum system is. So now, good. With this, you see here I said that there must be instant travel. We need to know that time has two identities. Energy also has two identities. Time by default is instant. When time is in relativistic scaling with energy, it becomes continuous. Energy, on the other hand, is infinite by default, but when it is in relativistic scaling with time, then it becomes discrete. We need to know that. Now, the instant trajectory of time is so essential for us to get reality. Don't forget that by the virtue of relativity, there is going to be an emergent central point between two objects. Now, if the two objects should approach each other, then it means that they will be approaching each other at equal speed. So they can never meet each other at exact position. But then, if the two objects have traveled, inversely to each other such that one is out of sight, it is then necessary for the other object to travel at the speed of time if that object must locate that lost object at its exact position. That is the picture I'm trying to paint right here. But then you can now see that instant momentum is highly needed. Instant momentum is needed for us to know reality, because the reality we're trying to get is the reality of getting to meet particle at its exact position. But then don't forget that the EPR paper concluded that quantum mechanics is incomplete. And from the time energy wave model, we have seen that because at the quantum level, the electron of the substrate dimension is undefined. Not until when it is connected to, electron of the higher dimension, such that that is, instantly flipped to be positron, for us to now have the instantiation of the substrate dimensions electron. You understand? So when we now consider that, we get to know that indeed quantum mechanics is incomplete. You understand? But then quantum mechanics is complete at the point where it's able to get connected to the positron of the higher dimension at the point of quantum entanglement. It is that quantum entanglement that we actually, return feedback, instant feedback to the classical mass worth. And that is what we see. That is what we'll experience as objective conscious experience. So if you want to know more about consciousness, I have a video on that. You understand? But basically, we now get to know that even classical mechanics is incomplete, just as quantum mechanics is incomplete. But at quantum level, at classical level, we could, get deterministic results because the H bar is too tiny to be significant. But at quantum level, the H bar is huge to cause uncertainty. But then the virtue of that reality, it comes from that complex system. At the point where we have entanglement is when we have that self-awareness at classical level as well. So that is that. That being said, then so now we know what complex system is, we know what classical system is, we know what quantum system is. Now, axiomatic condition for reality. What will now be the axiomatic condition for reality? Now, observation and experience are the two means by which one can obtain reality. It turns out that either of the two cannot ascertain reality when relativity is involved. By having relativity, when you move, the other part too will move. On the other hand, there is no emergent reality without relativity. Yes, I said that no point can be instantiated in space without having an inverse of it. It is when there is inverse of that point relating to it that we can say one point is the point of the past while the other point is the point of the future. So now, observation is delusional of reality relative to experience based on localization. Meanwhile, experience is delusional of reality relative to observation based on globalization. Okay, that is that. But then, what will now be the potential solution of reality? What will be the potential solution of reality? The potential solution of the reality will now be by the condition above, rather, that's what I wanted to say. By the condition above, localization and globalization must cohort. Experience and observation must be unified via static and undulating field. That should be our solution. So now let's briefly dissect this. I call this testing experiment. How can we get to, evaluate this axiom to say that indeed that should be, that should be the solution, that should, give us the reality. Now, let's look at finite notation. If you want to say something is finite, how can you get to say that something is finite? You can get to say something is finite when it becomes a proper subset of something. So it will not be equal with that original thing, and so you can get to know its end and its beginning. To have that, the formula will be 2n minus 1. But then 2n minus 1, if you say 2 times 1, you get 2, you minus it by 1, you have it to be 1. If you say 2 times 2, you get 4. If you minus it by 1, you have it to be 3. What this formula will generate will be odd numbers. Okay, so now, transiting notation, there must be a transiting point. So that transiting point, what will it be? The transiting point will be 2n, and that will be equal to even numbers. Even number is the point where you have the symmetric nature of the universe, the symmetric nature of time to energy being exhausted. It's the point where you have, the curvature of time to energy to be exhausted in order to generate standing wave that will connect to the higher dimension. So, even number. Then infinite notation, what will the infinite notation be? So if anybody tells you that it could give you the definite end of natural numbers, you can just ask the person to add 1 to the biggest number, and it will continue like that. That will generate infinity for you. But then if you look at this formula, 2n plus 1, 2 times 1, 2 plus 1 will give you 3. Then 2 times 2 will give you 4. When you add 1 to it will give you 5. Now this will generate odd number. This formula as well will generate odd number. So that is telling us that the finite instantiation is the same thing as infinite instantiation, and that is why our answer, we can get it in form of countably infinite pairing, because if the infinite momentum could be held, and then finite momentum could be held, then it means that even the finite instantiation, which has to be the subset of the infinite, can actually be paired with infinite and then be at par with it, or be tallying with it. That is what that is telling us. So now we have it to be heard. So now, natural numbers, if we say we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, infinitely to n, then proper subset of it, which is even, will be 2, 4, 6, 8, 10, infinitely to 2n. You can see that when we now take out the natural numbers, and pair it with even numbers, we can actually have equal amount of even numbers to natural number. This was actually done by Cantor, you understand? So by having it, we call it countably infinite pairing, and that is telling us that even infinity has to be instantiated as entity for us to be able to work with it. And so with that, you can get to know that reality of the universe, or the measurement problem reality, is the point of static and undulating field, where we can have the cohorting of observation and experience, or the cohorting of globalization and localization. So that is that. We have to call it a day. So I'm going to put a link to my research publications in the description below, and then you can subscribe to my YouTube channel to get to know, to watch more of my video. Thank you. God bless you.